Video we are going to look at homework 4, which is the homework on loops. If you look on the website, it just says to check it out, so I'm going to check it out. Get rid of my previous copy. Okay, so it copies over 3 files, and normally if there's a file called Readme, that's the one we want to look at first. I'll put a link to this video in the file. So there's 2 things to do here. One is I want to see your current cheat sheet. So however you're keeping a cheat sheet, or if you're not keeping one, then do one. And it should include all the Linux commands, shortcuts that have been quizzed on, all the Python operators, functions, and keywords that have been quizzed on. I want to see them all there in a way that's useful to you to remember how exactly to do things. Ideally, 1 piece of paper worth of cheat sheet total. So if you're doing this in a notebook, then front and back of a piece of paper is kind of what I'm looking for in terms of being useful for you. But if you're doing something longer, that's fine. And you're going to get that into your account, and we'll do a separate video on transferring files. But you're going to put in a file answers.txt. There's a file answers.txt, and you're going to put the name of the cheat sheet, so whatever you're calling it, and it could be a JPEG, or it could be a PDF, it could be a text file, docx, however you're keeping it is fine. But then whatever that name is, so this answers.txt is just for me to read. The hand-in system doesn't know how to read this file. The hand-in system knows how to read the file manifest, and you just put 1 file name per line. So all the files that are going to be mentioned in the README, we're going to put the file names in here. So what did I call that? Cheat sheet.docx. So if I want to have something called, this is not actually a docx, but just to have something there, so that if I hand in, I can hand in like this. Okay, and so then it handed in my answers.txt and my cheat sheet document. Looks like there was also an empty line at the end of the file that it didn't like. Okay, all right, so let's check out that README. Problem 2 is asking you to come up with answers using the programs that use loops that have been worked on mostly by Jeff, and a few also by Adam. Okay, so each of these is asking for some particular question, and it mentions a file that might be useful. I'm just going to go and do the first one to show you what I'm talking about. Okay, so a perfect number is one where you add up the divisors other than itself and it equals itself. So for 28, we've got 1, 2, 4, 7, and 14. Those are the divisors of 28, other than itself, and if you add them up, it happens to be 28. And that isn't particularly useful for anything, but it's kind of a cute fact. All right, so the question here is, what is the next perfect number after 28? And the suggestion is to look at this file for help. And this file, you can browse to it in the system, but if you want to look at it in the browser, there's the direct link. And I'm just going to copy and paste. This is 2A. I'm going to call this file 2a.py. You can name files whatever you want, and I'm also going to open up another terminal because that's a good thing to do when you're developing code, so you can have it in one spot and then run it in another spot. Okay, so I just want to run this. It tells me, and let's type 28. So what it did here is it's checking for the factors of 28 and adding them up. Okay, so I could run this and type 29 to see what happens with 29, with 30. There's going to be too many to try. You could do this for all of them, but there's going to be too many to try. So first of all, I'm just going to say n equals 28. I'm also going to not print, and then I'm just going to print the total. So I'm not going to print all the individual divisors, just the total. Okay, so now I see total is 28, and I'm going to make an if check here. If n is total, then I'll say perfect. Otherwise, print not perfect. Okay, it happens to be perfect. If I change this to 29, not perfect. Why don't I go ahead and print the number as well? Okay, so then the thing to do is just try numbers until one of them works. And this is the thing, I just need to change this right here. And I could use a while loop to do this, or a for loop. I'll show it with a for loop first. So instead of saying n equals 29 there, I'll say for n in range 29, and I'll just say 1,000. And then everything here I want to be part of my loop, which means I'm going to space it over one more level. Okay, so now I have, for every n in this range, I'm going to start a total at 0, check all the divisors, check all the possible divisors, the ones that actually are divisors, add it to total, and then I'm going to print for every single one, whether it was perfect or not. Or maybe I only want to print the perfect ones. Otherwise, it'll be a lot of stuff printed. And it gives me 496. So there's my answer. Let's see what else we get. This is not a very efficient program. There's much more efficient ways to do this, but we get the next one as well. All we need for the, so this is my file that I used to figure it out. And if I go back to my answers, let's see, let's look at the Readme over there, and I'll look at the answers over here. Okay, so the question is, what is the next perfect number after 28? It is 496. And what is my Python file that I used to figure it out? 2a.py, and I need to put it both here and also in my manifest. You put it here, that way I know which file goes with which problem as I'm looking through your answers. I'm going to check your answers, make sure you got the right number. or whatever it's asking for, and then I'll go and check your code. So something that's written here is if you just give me the answer, that's not going to count for anything. What I want is I want you to figure this out, to have code to figure it out. And for each problem, there's a way to do it by taking one of the problems that we did in class and modifying it or running it, adding a loop to it like we did in this one. And most of these you can check online. So for the next problem, on this one, it's actually asking you to verify this by looking up the formula for a perfect number. You could ask the internet here. So there it tells you. All right, so we've got it. So the questions here, I think all of them maybe, but anyway, the ones that have an answer that you can look up, I'm having you discover the answer yourself and then verify the answer that's on the internet as well. You'll have to read through. So let me just, let's see. Let me explain one more. I'll just say something about each one. All right, so this one here, it's asking you to check. This is a formula that if this happens to be prime, then this might be a perfect number. So go ahead and print out these values for k going from 1 up to 10. Okay, so this is 2 to the power k minus 1, and then times 2 to the power k, and then divide by 2. So what are these values? And we should see 28 in there, and we should see 496. And we'll probably also see this one, but we'll see potentially some other numbers as well. It doesn't say that you're guaranteed to be a perfect number, but you have to be, if you're like this, you might be perfect. Okay, this one here is asking you to add up the numbers from 1 to 100 with a loop. So you're basically going to be calculating 1 plus 2 plus 3 plus 4 plus, and so on. All right, and you should come up with a number. You're going to put the number over in your answers file, and whatever the name is of your file, you're going to put that over here and in your manifest. There's a formula to tell you what that sum is, and the formula is this. Okay, so you should also check that. N times n plus 1 over 2, where n is 100 here. You can ask the internet. Okay, so that's probably the answer you should get. You have to do the code to make sure. And then it's asking you for what's your one line of Python code to check that. There's the formula, you can check it by running that one line of Python code. They go along like that. A few that are they're a little bit different. So this one here is asking you, this is a coin flipping program that it flips 10 coins and tells you heads or tails each time and then adds up how many heads. So you're supposed to put this statement here. So copy that, put it, make a copy of this file, or copy paste this into some code, and you're going to put right here, before you do any randomness, you're going to put that random.seed 7. What that'll do is we're all going to get the same random choices. And then the question is, how many coin flips until we get 15 heads? We should all get the same answer. So you're going to run this not 10 times, but you're going to let it keep going, maybe go 100 times, and then you have to check what is the value of I. So how many coin flips are we at? Or what is the value of I plus 1 when this heads count gets to be 15? Okay, then question I here is a little bit different as well. It's asking you for the percentage of the numbers that are prime in each range. So what percentage of the numbers in the given range of integers are prime? So between 1 and 100, there are 25 primes, and there's 100 numbers, so that's 25%. You're going to write a program to do this, and you want to look at this program as a starting point, but you need to actually go through the numbers to make sure that yes, 25 of them are prime. Okay, and then so you're going to run it with this range, your program, whatever you come up with, and you can use the internet to check to make sure this is the right answer, but I need to see your program. And then in this range, do you think it's going to be bigger than 25 or smaller than 25%? And then this one, does it get bigger or smaller? That's why I gave you the range, because it's interesting. Okay, this one is asking you to run this program from Adam. Look at the numbers and understand what it's doing. And so that's going to tell you what is the largest value of k, so that if you raise the number to itself, you end up less than or equal to 10. So let's just try it on a few numbers. 1 to the 1 power gives us 1. 2 to the 2 power gives us 4. 3 to the 3 power gives us 9. Okay, so if we look at 10, let's see, what's the next one? 4 to the 4 power is something bigger than 10. Okay, so here, no, 3 to the 3 power is 27. Okay, so the answer for 10 here would be 2. Because we get 2 to the 2 power is less than or equal to 10, but 3 to the 3 power is bigger. Okay, so for each of these, we're going to have these values. In this program, if you run it, it does have those in there if you adjust the program the right way. Okay, so make the program so that we're going to see all of these values, however many we need until we get up past 1 million. Okay, that's it. So you're going to make sure that you get the right answers here. You can even ask me if your answers are correct, that's fine. And you have to have code to back it up, or it's not worth anything. And I don't want you looking for code. This is the code that you can use. Don't search. So this would be considered, I'll give you a 0 and flag you for cheating with the university if you go, how many cubic numbers less than 1,000 in Python. Okay, no. You have enough. These files are enough. You can search for general help about Python, but not what percentage of primes between a range are whatever in Python. Okay, some of these you might be able to find a program online that'll do it for you, but that's not the point. The point is you want to figure it out based off something that's kind of in the right direction. All right, good luck. And then ask for